Let us look at quadratic equation part 3. Now, remember the quadratic formula? Now, let's focus on the expression inside the square root. So, b square minus 4ac, there are three possibilities. It could be greater than 0, it could be less than 0, or it could be equal to 0. So, let's take each of these cases one by one. Now, when b square minus 4ac is greater than 0, again there are two possibilities. If b square minus 4ac is a perfect square, the square root evaluates to a rational number. Hence, the roots are rational. Perfect square means we can get a rational number. So something like square root of 4, square root of 16. So that will simplify to a rational number. If it is not a perfect square, its square root is irrational. Hence, the roots are irrational. So let's look at an example. X square plus x minus 1 is equal to 0. Here a is equal to 1, b is equal to 1, and c is equal to minus 1. So let's apply the quadratic formula. We have x is equal to minus b minus 1 plus or minus square root of b square, that is 1 square, minus 4 times a times c divided by 2 times a. Now we simplify, we get minus 1 plus or minus square root of 1, minus times minus is plus 4 divided by 2. Further simplifying, we get minus 1 plus or minus square root of 5 by 2. Now here square root of 5 is an irrational number. That means the whole expression becomes an irrational number. So in such cases, the roots occur as a pair of irrational numbers. Now, why pair of irrational numbers? Because of this plus minus before the square root. So here we have x equal to minus 1 plus square root of 5 by 2 and x equal to minus 1 minus root 5 by 2. Now let's take the other case. B square minus 4ac is less than 0. So let's take another example. X square plus 1 is equal to 0. So we can do it straightforward. X square is equal to minus 1, which implies x is equal to plus or minus square root of minus 1. Or if we want to use the quadratic formula, then remember b is equal to 0 here. So we can write it like this: x square plus 0x plus 1 is equal to 0. And applying the quadratic formula, we get minus 0 plus or minus square root of 0 square minus 4 times 1 divided by 2 times 1. Simplifying it, we get plus or minus square root of minus 4 by 2. So x is equal to plus or minus square root of minus 4 by square root of 4. So what we have done, we have taken this 2 and we have taken it in under the square root by taking the square of it, which implies x is equal to plus or minus square root of minus 4 by 4. So x is equal to plus or minus square root of minus 1. This is tricky. X is equal to plus or minus square root of a negative number. So let's hold on to this. Now let's take the third case. B square minus 4ac is equal to 0. Let's take another example. X square minus 2x plus 1 is equal to 0. Applying the quadratic formula, x equal to minus 2 plus or minus square root of minus 2 square minus 4 times 1 divided by 2 times 1. Simplifying, we get x equal to 2 plus or minus, this is 4, this is 4. So 4 minus 4 is 0. So square root of 4 divided by 2. So x is equal to 2 plus 0 by 2, because square root of 0 is 0, which is equal to 2 by 2, which is equal to 1. That is if we take plus. But the minus is also there. So x is equal to 2 minus 0 by 2, which is equal to 2 by 2, which is equal to 1. So here there is one real repeated root. Or we simply say that the root is 1 and has multiplicity 2. Okay, now the square root of a negative real number is not a real number. So coming back to this, x equal to plus or minus square root of minus 1. So square root of a negative real number is not a real number. Such numbers involve the imaginary unit I is equal to square root of minus 1. So the square root of minus 1 is denoted by I. So we could have written here x is equal to plus or minus I. Together with the real numbers, they form the set of complex numbers denoted by C. Every complex number can be written in the form a plus ib, where a and b are real numbers. But because of this I, we say b is the imaginary. Therefore, we cannot find them on a number line. Now, non-real complex roots occur in conjugate pairs. Non-real complex roots occur in conjugate pairs. Now, this is very important to understand clearly. Irrational roots obtained from the quadratic formula occurs in conjugate pairs. What are conjugate pairs? Everything else remains same except the sign before the square root. So if there is plus here, then minus is also going to be a root. Non-real complex roots occur in conjugate pairs. Again, plus or minus before the square root of minus 1. Every non-real complex number has a non-zero imaginary part. This is where we come back to this previous point. Every non-real complex number has a non-zero imaginary part. Remember, complex numbers are a plus ib. So complex numbers which are non-real will have non-zero imaginary part. And every real number is also a complex number with imaginary part 0. So if 2 is a real number, then it can be written as 2 plus I0. So that imaginary part becomes 0. So, but still it can be written as a complex number. So every real number is also a complex number with imaginary part 0. Since the set of real numbers is a part of the set of complex numbers. So as we have seen with these examples, the quantity b square minus 4ac helps us identify the nature of the roots. It is called the discriminant denoted by delta. And we can do the classification of the roots based on this delta. If delta is greater than 0 and square root of delta is rational, we get two rational and distinct roots. If delta is greater than 0 and square root of delta is irrational, we get two irrational and distinct roots. If delta is equal to 0, we get two real and equal roots. Or in other words, one repeated root. If delta is less than 0, we get two non-real complex conjugate roots. This is another way of looking at this. Instead of looking at b square minus 4ac, so think of it like this. If b square is greater than 4ac, then it's going to be a positive number. If it is equal, they both cancel out and we get 0. Square root of 0 is 0. So two real and equal roots. And if b square is less than 4ac, what happens? We end up with a negative number. So two non-real complex conjugate roots. Now, in the previous session, we saw the axis of symmetry. So the roots are x equal to minus b plus or minus square root of b square minus 4ac by 2a, which we can split it into two fractions, which is minus b by 2a plus or minus square root of delta by 2a. This we can write it as two separate expressions, x equal to minus b by 2a plus square root of delta by 2a, and x equal to minus b by 2a minus square root of delta by 2a. So the roots are equidistant from x equal to minus b by 2a. So hence for a quadratic curve f of x equal to ax square plus bx plus c, the line x equal to minus b by 2a, which is the line passing through the midpoint of these two roots, is the axis of symmetry of the parabola and passes through its vertex. There, in the previous session, we looked at it through an example. Now I'm generalizing this. One very, very important point. The word root has two common meanings in mathematics. Roots of an equation are the values of the variable that satisfy the equation. Root by itself usually means a square root. So be very clear based on the context whether we are talking of roots of an equation or the square root. So that was quadratic equations part 3. That's it for now. Bye.